profile of any line. This is profile line, profile of any surface. This is not used to, not often used. And orientation, the parallelism and the perpendicularity, the angularity, position, the concentricity and the complexity, the symmetry, the circular runout, the total runout. So this is different. It's different. The circular runout is to measure the points, and total runout is to is a lot of the points like a line. So the form tolerance items is not data. They restrain the form error of actual features such as line, surface, circle, and the cylinder. So there are just the two compartments in the tolerance frame. So that is the contour feature. I like the class I address the contour feature and the central feature. Do you know how to tell the contour feature and the central feature? No. The contour feature like the form tolerance like the line, surface, cylinder, and contour and central feature like the axis, parallel axis, and the median plane. That is very important to tell the actual feature, the contour feature, and actual feature. Like this is the shaft. Right? This is a keyway. So this is axis, right? So this is the cylinder. This is the contour surface. Contour surface. Future. Future. Like this, we have to touch it, and this surface, the inner surface. This is also a contour surface, and this is the contour surface, and this line. The line is the form tolerance. Is the form tolerance is a line. So this is this line is a contour surface, and this cylinder is contour surface. And this one, the axis is like the design data. So that is this axis is a center future, right? And this keyway, this is the median plane. The keyway's median plane is also a center surface, center future. You understand? Okay, continue. So there are just the two components in the tolerance frame. And this class, the important content is how to write this frame in the drawing. How to draw the frame. So except the straightness, flatness, circularity, and the cylindricity features are always contour feature. Like this one too. This is straightness, like this one, straightness. But when the when this error is in line with this dimension error, that means that this frame or the tolerance frame with this frame to describe the axis. the axis tolerance. So for the axis tolerance, we use a cylindrical to constrain the axis. So we need to add a y. You understand? Understand, right?
No.
But this one, the phi, right? Because this is the surface. The surface, the tolerance, the surface like this. This is the line because the surface. So we use this line and the actual line. This is the t. The tolerance t, right? But what is the axis? Axis line. So we use a cylindrical to restrain this line, right? So his tolerance is we use L25, right? So the string length features may be contour features and center features axis of the cylindrical. Like the center features will do at the theta, at the phi, sorry, at the phi. Okay, this is very important. So string means a condition where all points are in a straight line. Usually, the tolerance zone is limited by two parallel straight lines, like this one. Like this one is limited by two parallel straight lines. Sometimes the tolerance zone is limited by a cylinder of diameter t if the tolerance value is preceded by 75, right? Like this one, this is the cylindrical. A cylinder. And so this is described the axis tolerance, right? Okay. And this one, this is the surface. This tolerance. This straight tolerance is limited by straight line. So this is the surface. So this is no phi, right? And also the error needed to point to limit to the surface. To describe the surface. And this is the same. Is describe the surface tolerance. The line in the surface. So this is no phi. The tolerance is limited by two parallel planes. This is by parallel plane. A distance t apart. So it quantity during any extracted or actual generated line on the cylindrical surface is contained two parallel planes 0 to 1 apart. So this is his tolerance is 0.1 apart. So flatness. All the points on surface are in one plane. So the tolerance, like this one, this is the surface. The surface is the tolerance. The surface tolerance is 0.1. We use a very flat plane to contain the actual surface. So his tolerance is 0.1. When we measure the surface, his tolerance is 0.1. His actual, this is his theoretical and his actual flatness is 0.1. We said it is available. The part is available. The tolerance specific by a zone formed by two parallel planes. And the tolerance value is the distance between the two parallel planes, like this one, two parallel planes. All the points at the actual surface should be between the two parallel planes, right? It's very easy to understand. And the circularity is the same. the circularity. All the points on a surface and a circle, right? This is circularity, this is the circle. And the tolerance is specific about zone bounded by two concentric circles. So this is the circle. So we use a concentric circle to contain the real circle, not real circle, right? So we use two circles to contain the real circle. So this is 0.02. So this one is 0.02 is circle tolerance. Right? So the tolerance value is the difference of the two circle radius. And so this is the cone, right? The circular cone. But because we need to describe the circle, so the arrow leads to perpendicular with this axis, right? And also, so this is the circle. It leads to perpendicular this circles, this axis. So this is the line because it's the circle. We need to describe the circle, right? When we need to describe this line, this line current we need to have perpendicular this line, right? So this is to describe the circle, right? The circle on this line is to perpendicular this axis because we need to this is the circle, right? When we need to describe the line tolerance, so we need to parallel this line. Got? Cylindricity. All the points on surface of the resolution are equidistant from a common axis. So the cylindricity it will to address this is the to describe the surface. Right, so the surface. So this tolerance is 0.005, like this one. This is his geometric. The cylindrical geometric. So like this is the real cylindrical. So this is we use a very theoretical geometry to contain the real geometry. So this the radius is 0.05. So all the points of the surface of the revolution are equidistant from a common axis. A cylindricity tolerance specifies to a current zone bounded by two concentric cylinders with which the surface must align. The tolerance values is the difference values of the radius. So like this tolerance. The tolerance it means this is the radius. The radius is this t, right? This is the orientation. So like the form in the data, right? In the data features in the data because it's to describe this form, the form tolerance. But from the orientation, when the parallel, it means that some features need to parallel to another feature, right? Nothing. So like this one, we need the data feature, right? That work. Like the parallelism of perpendicular and angularity. The first one, something you have question? Any question? The parallelism and the perpendicularity and angularity. The tolerance features may be a line or a plane. The data features may be a line or a plane. The tolerance zone is between two parallel planes with a cylinder surface. So pay attention to that. The tolerance zone must follow the specified orientation to the data features. When the tolerance zone is a space with a cylinder, the tolerance value must be a preceded by 5. So, like I suggested before, if the tolerance value is a space with a cylinder, like this axis is a space, is cylinder, so we need to proceed by 5, right? So the parallelism, the condition of a surface or axis parallel to data plane or axis. So this is the tolerance feature. If this is a plane and need to parallel another plane, so data is a plane, and the tolerance is a line parallel a plane, right? A plane parallel a line parallel a line. So there are four different types. The first one is parallel to a plane, plane to a plane, like this one. The tolerance zone is a space between two parallel planes. So like this one, this plane to parallel this plane, right? So that is a frame. So this is a parallel lane, the cylindrical symbol, right? Parallel, and the point 0.01 is like this plane and this plane. This is the data plane. Data plane is the D. The D is here. Data plane, and the tolerance zone is 0.01, right? We need how to write or how to draw the frame, the tolerance, the geometric tolerance. The tolerance value is the distance of the two planes, right? Like this one, the tolerance. The tolerance zone is the space between two parallel planes, and the two parallels must be parallel to the data plane as well. Like this one. So this is the axis. This is the plane. The data is here. All the points of the tolerance line must be between two parallel planes. So this is the parallel. This is the data plane. So data plane. So like this axis. This axis need to parallel two planes. Between two planes, right? So all the points of tolerance line must be between two parallel planes, and the two planes must be parallel to the data plane as well, right? So this parallel plane has to parallel this data plane. The tolerance value is the distance of the two planes, so the T, so no 5, right? But this data is the plane. And another one, plane parallel to line. The tolerance zone is the space between two parallel planes. This is the plane, right? But this data feature is a axis, like this one, because this data feature is in the line of the dimension line. This means that this data is the axis data. Okay, this axis data. So like this plane, this is the geometry of the plane. The data is a line. So this one is like the plane parallel to a line. the tolerance value is the distance of two planes. It's also a plane because this plane parallel to the data line. So a line parallel to a line may be a specific one direction or any direction. So this is the one direction. This data is here, right? It's A. This is the new standard. That is old standard. So this is his data. This data is the data is this line because it's in the surface. It's this line. So this is the data. It's a data line, right? But this one, you mean this one? This one is center, the center future. So it's a data line because the data is in the dimension, in the surface. But it's in the dimension 9. Dimension arrow, dimension 9 is in the line to the dimension 9. But this one, I think this is also a center line. Tell me the difference of this one. This is this dimension. This one, when a line parallel to a line is a specific one direction, the leader arrow must be perpendicular to the direction. Let me see. Okay. Huh? You understand this one? I'm confused.
When the arrow is in line with,
I mean, this one is in the line, so it's in the line.
this statue is for
Yes.
the straight one,
Yes.
but this statue is for this one.
Yeah. But this is a line.
Perpendicular.
Yeah.
This one is in line with the statue. It's in line with the arrow is in line with the statue.
But this one is also the line, right?
Yes, it's also this one.
But
This
this-
line is perpendicular to this
For
one.
this one, so this is a line, but I think this is a line, not a plane. This one is the center line. The center line, right? The center line. So this is the center line. So this is means that the line to line.
Yes, so it's that one.
Hmm?
That one is that.
It means that this line to this line.
Yes.
So this is a parallel. I think it's a parallel. Sorry. So this I think is a cylindrical line. Cylindrical line parallel to this line. Like to line parallel to is a line parallel to line. So that means that I think we need to a lot of space. So, I got this is the line, right? These are two planes like this direction, like you said, this direction, right? So this line is this direction, but if I describe here, let me see here like this one. Like this one, and this one, and this is the dimension line, and like this is the arrow line, right? let me describe it. This is simplified. This one simplified. This one, okay. This is the whole. This is the whole, right? This is the whole. So this is the whole. It's very simplified. So when we choose this is the whole. When we choose like to verify like this one is 0.2 and data A. Data A is here. It's the same, right? So like this picture. So I think we need to add a 5. Right? Because in here, this is no direction. Now this one, because we describe in here relative restraints in here. This is the picture. This in this picture they have a direction, right? The direction is means this line is this direction or this direction or this direction. And here, this space is not direction, it's any direction. If in the any direction, we need to add a 5. You understand? This one. So this one is means this direction is describe this line. This line is this direction. So this is the axis, right? This is the axis. This axis is describe this direction. This direction. So this is the one direction. Also, this direction, the tolerance geometry is a plane. And also, so this is this direction. So this is the axis to the inside in. The direction is in. That his direction is so this direction is in. So his direction, right? So his direction is this plane. So this is a plane. So this is a plane. Geometrical torus is a plane. And this also is a plane because this is to a direction. Is one specified the one direction. But this one, because we draw the frame in this picture, like in this picture. So this is also to describe the axis. So this axis is means to a cylindrical line, the space, right? The space is also his geometrical form. Geometrical torus is a cylinder. Or cylindrical, right? Cylindrical. So it's so we need to add a 5. I said. The location tolerance, that is orientation tolerance, is a parallel and a perpendicular and ordeals. So the location is the position, causality, and symmetry. Right, symmetry is location. This is position. This is symbol, right? So this is causality, right? The symmetry. The causality, the axis of all cross-section elements of the surface of resolution are common to the axis of the data feature. Like this one, the causality tolerance specified a cylindrical tolerance whose axis coincide with the data axis. Like this one. So his causality, this is his axis, right? So it's a cylindrical. Like this one, so this arrow is in the line, in the line of the dimension line, right? So it means it describes this axis, right? The axis. So this axis is coaxiality to this his data. A to B, A is here. A is also means this axis, right? This axis. So when manufacture this surface and this surface and this surface, it means this axis is causality to this axis and to this axis, right? So this data means this axis. This data is in this axis. So this axis is causality to this axis and this axis. Its tolerance though is 0.1. So it should to add the phi because this is the cylindrical. Yeah. Yeah, and also don't forget why this is here. Don't forget the phi before the tolerance value. We learn to add the phi. I also stress that. The symmetry. The snout requires a symmetry with the media plane. This is the media plane, like the keyword. It's mostly described, the keyword is parallel, okay? And also described here is parallel. So not parallel, it's the symmetry. It's symmetry. The snout requires a symmetry with the media plane. With the media plane. In this case, the tolerance zone in the space between two parallel planes 0.08 apart. Like this one. So this means the media plane, because in the line, in the arrow line, in the dimension line, this in the dimension line, it means this parallel, this media plane, right? This media plane is too symmetrical to this data, the axis, right?
This is not cylindrical. This is not cylindrical.
It's symmetry.
It's not cylindrical.
It's not cylindrical, but it's a plane.
But if a cylinder is supposed to coincide, cylinder is coincide.
Cylinder.
Like the other, just like cylinder is coincide. That two line is aligned with the center line.
Yeah.
Which means it's also symmetric.
Symmetric.
Yes.
You mean this line means this media plane, because this is not a circle.
Yeah, but what I'm asking, circle comes symmetric.
Yes.
So if the circle has coincidental, that is in line with the center line. So symmetric, like what you go back. One.
This one.
Yes.
Yeah.
Symmetric.
Yeah, symmetric. This is symmetric.
So symmetric and also coincidental.
Is symmetric or
This is coaxiality.
coaxiality.
Yeah.
Yeah.
So even though it's coaxiality, it's also symmetric.
Yeah. This is the coaxiality. It means that this axis is coaxiality to this axis and to this axis. Because when we make the part, we turn this surface. When we turn this surface, this is an axis, right? And we also turn this surface. We also turn this surface and call this axis. So it means that when we make this apart, we need to meet this axis is coaxiality to this axis.
My question is, even though it's coaxial, it's also symmetric. Right?
It's also yes, but it's according to different type. If not coaxiality is like this one, this is the axial, this is the center feature, right? But this is not to element phi because this is the one direction.
Specified that.
Yes.
Potential meaning. That's in line with the single line. Second, which means you have it's an axis and a bit.
Deadline should not also be
symmetric that way.
After you see this picture, that is reality alpha because this is a space, is a cylindrical line to line. So it's like this one. So this is not add because this is a plane. This because this is not, this is a snout, right? So like this is frame to start or to point. This frame line. This line or the arrow line is in the line or the dimension line. It means this medial plane. So the medial plane is symmetry to this axis, right? The axis. So his tolerance is 0.08. 1.5 apart is t divided 2. This is 0.04. It's up 0.04. It's down 0.04, right? So the position. The position. Right, any question? 3. The position. This is very, very, I think it's a little confusing. Like the position tolerance. 3 motility for perpendicular, right? Perpendicular plane data system. So this motility for perpendicular plane data and theoretical exact dimensions. It means that is the theoretical exact dimensions. So it to determine his exact position. Like this one, the data system. The primary is this is a data. This is a symbol, right? It's a position, right? So this is A, B. This is primary data and secondary data, and also sometimes is a third data. So like this one, his is a position here, and we need to describe this circle position. When the circle position is in this big circle, this is a bigger circle is this one. It's bigger circle. Cylindrical is also cylindrical. It's a big circle, and this one is also this is a circle. So we have a dimension. a relative dimension, and this is a line. So this is this one, right? Is this one. So this one, when the data B is here, B means this cylindrical line. Sorry, this is axis line. This axis. This is this axis. So this axis and this dimension is determine this position, right? When we draw this picture, the figure, and we draw what big circle and this circle and this circle, and this dimension, the radius to determine this position, right? And also because we need to describe the axis. Actually, this is the axis, not this circle. So this axis, this whole axis, like this one, this axis, and also this axis is also perpendicular this surface. Dot. This axis perpendicular to the surface. So this is theoretical position. So it means that this line, this axis line, is not a theoretical position. It has a phi 0.010 is error. Yeah. Now the error is tolerance. The tolerance. Like this one and this one, is the difference is that this one means this A is the primary data and B is the secondary data. So it means B is the theoretically position. So B it means this axis line is theoretically in this circular line. Is in the point in this line, in this axis. Theoretically, it means this no data, no error or no tolerance, and A. It means that it should to meet the B like this. B is this axis, so it's related to. It means that this circle is theoretically in this circle. This small circle is theoretically in the right position in these circles, and then this axis line is not very perpendicular to the surface, so it's not a straight. But we show this one. This one is the position, and this B and A. B is this one. This means this line is perpendicular. This A is the surface. So this line. So this line is parallel to this surface. This N means this is a bigger material procedures we need to learn later. Yeah, it's M. Is how to design the tolerance. No, this is I think it's bigger material principle. Principle is M. The principle. The tolerance principle. This is a little hard. The position. And we see more examples, okay? Huh? Stand for physics. Or phrase break. Okay. A break.
Yeah. Time.
It's time. Okay, we have a break, short break.
Yeah.
Okay, class study. Class study. And I want to suggest the position tolerance. Like this picture, this is a sample picture, a sample one. This is a part. This is a part. This is the structure. This is the whole. This is a part. This is a sample. This is also a sample. So this picture is mean that the different the data A and data B in different position is also to affect the assemble function. Yeah, because this is M, right? I have to say M. It is a word. So the M is means the maximum material requirement. That is the tolerance per simple. Tolerance per simple. So most of the tolerance is means the most tolerance the per simple is the independently per simple. It means that there's no relationship with A and B. So it means that A no relationship to the B. So they are independently. Like this one A, B, C. There's no independently tolerant independently. But this one is material requirement. It means that A is related have the relationship with B. So is the maximum materials requirement. Because most of the per simple tolerance per simple is independent per simple. Is that A, B, C no relationship. And 10% is in the maximum material requirement and another principles. So I don't want to explain it very well. So I need you to see the book, watch the book, and understand it. And yeah, this M is maximum material requirement. Which page? Page 112, 112. That is the person. That is the in.
MMR.
Yes, MMR. And also the envelope requirement. So mostly it's the independency per simple. And some observation requirements. So, and another one, back to the class, okay? So another one is on the drawing, the TD. TD is the theoretical exact dimensions, because when we describe the position tolerance, the basis is the theoretical exact dimensions. So it's enclosed in a box like this one. This is its position. This is the position. How to determine this circle's position? We need to have the dimension, right? Like this dimension, this is the 6. So this dimension, it means that this hole is in the box, right? And also it has this dimension, and it can to determine this position. So that position is A. A is here. This is surface. So it's parallel to this A. It means that this axis is parallel, not parallel. Its axis is perpendicular to this surface, right?
Yes.
to this surface, like this 90%, this surface. And this phi is t. So this is cylindrical. Cylindrical is to parallel, is perpendicular to this surface. And actually, I think is lead to a b like this surface, this data, and can to determine his position. But he just to have tolerance of is a tolerance with to this surface. So we meet the requirement is that this is data A is this surface, and this axis is parallel, is perpendicular to this surface, is T. Okay, and the tolerance like this one. The tolerance though is limited by the sphere of the diameter T, like this one. This is we need to see this sphere's point. This one is to his point. His point is the sphere. So this is S sphere and it's phi delta 0.3. So this is how to determine this position. This position is to the data A. Data A, so is a 30 millimeter, right? Its dimension 30 millimeter is surface. This point to this surface is 30 millimeter, and to this surface is this data B is 25 millimeter, and this is C. C is the axis. It means the surface is in the axis, right? So this point is point 0.3 surface 0.3 is tolerance, so is 0.3. That is available when you to make a part, make this part. So before the tolerance value number, there must be S phi. And this position is a little confusing or little loud data. You just to easier, you just to simply understand that how to learn this array. And also the position tolerance of a line. The tolerance of position though is limited by cylinder of the diameter T, the axis of which is the theoretical position. Like this one, this is also how to constrain or how to restrain this line, right? This axis 9. So the axis 9. So this circle, like this circle is between this surface is a dimension, right? To this surface is a dimension. So this is to point this line to district or to determine this line, this point, right? But this point, because this is a line, this line is also perpendicular to this surface, right? So like ABC is to restrict this position, right? Got? No? Huh? Because this is the we need to describe the position, right? This position is to this data. Because this is independent per example. So ABC is the relationship. So this is the position. This is axis, right? Because this is in the line. This axis is a line. Is a dimension line. So it's this axis. So how to restrict, divide or restrict this line, right? This line. So this line, I mean, this firstly, this point is to this surface is a dimension, right? And to this surface is a dimension, right? So to determine this point, right? This is a line or axis. So this axis is perpendicular to this surface. So it's to determine this axis, right? So this axis, because this is a cylinder axis, so it's a phi. Right? The round out. Okay, round out is defined by measurement method, and it also can be controlled by tolerance zone. This is a measurement method. It's defined by measurement method because it round out the shaft is to rotate very quickly. So there is a round out. The circular round out and the total round out. What is the circular round out? That the circular round out is radius. That is a shaft. So the shaft is round out. Round out is this surface, right? When it rotates very quickly. So this is a circle. Is a rotate. Is a circle. Is a circle. But because this is not very circularity, very not very circle, it's not a circle. So there is a restricted plane, right? The two plane. So this is radius is 0.05. This is the 1 point, right? To this axis. To this axis. So the tolerance is applied independently at any circle, measuring position, at any measuring position. And with this point or this point, as the part is rotated 330 degrees, it means that this shaft to rotate a circle. So circle round out tolerance applied to surface constructed around a data axis controls. This is axis, the axis data controls. Controls cumulative variations of circularity and coaxiality when applied to surface constructed at right angles to the data axis. It controls a circular element of plane surface, right? So this is the radius, and this is the axis. This axis is this. Is this one? The tolerance zone is limited at any radial position by two circles at a distance apart lying a cylindrical of the measurement, the axis of which the coincide with the data axis. It's the same. This is this end surface. This is the radius, right? It's the same. The same method to measure the cylindrical. I want to see how to measure the round out. This is a video. And we also to do the experiment. This is the Chinese, just to see the picture. We use the map. This is the and we rotate this picture. We rotate the shaft, and we use this one to measure the data. Huh? This is bad, okay?
对两个半径2元件的互动轴线 AC 的镜像元角度 大于其他值。
Can you understand?
检测方法是
You just use it means that this the method is
将微测零下放
we
在
use
微
the
零下上，
this one to measure
零下在微米毫内，
this runout.
实际上得最大最小，就是单个测量实践上的镜像
This is-
效果。沿微测圆柱面轴线方向移动直指，分别测得若干个截面，与其中
When you rotate this shaft,
镜像
so this
操作，
there are some values. You need to record the value.
用符合基准的镜像连套来做标准。其测量方法是将微测零下安放在两个顶夹之间，在微测零下回转一周过程中，实际读数最大与最小即为单个测量平面上的镜像效果。按上述方法测量若干个平面，与自截面
And you need to measure the different points. But this is
作为该镜像
still
的
point.
镜像效果。 观念原跳动检测方法，
This is axis. Axis.
以外圆
Axis.
观念跳动，像工作标准，测量零下大观点对外地圆柱面轴线观念原跳动不得大于其他值。测量方法是将微测零下放在微型架上，并经轴上定位，在微测零下每一周过程中，实际怎么
And this point is a still point. And to rotate this shaft. And this is the record the different values. It's the maximum and the minimum.
与测量圆柱面
And get the average data.
作为该形态观念原跳动。本测量方法受微形态表示和基准实际要素形状误差的综合影响。以孔的轴线为基准的观念原跳动，如图中标注的，测量零下上观念对基准孔外壁的观念原跳动误差值不得大于1。测量时，将新轴插入。
This is the fixture. And this is the part to use this fixture to contain.
与微测观念，以测量方式跟与基现实，然后在分析中由指数镜像选择最大的，作为该测量圆柱面观念。将指示器沿镜像做，分别测得若干个测量圆柱面，与其中最小值作为该形态观念原跳动误差。
看懂 this one, I mean this one. This picture. Just go to a device. Use the device to measure the data. So this is the shaft, right? We need to measure the runout. Because this runout we get from the measurement, right? Measurement method. So this is the shaft. This is the shaft. So we use this device. This is a point. This point to contain, to touch. This is the surface.
Actually, why we have to measure
Why to measure the 1 point?
more? So
More. You mean that measure the one more than 1 point, right? Because this is a circular runout, and also there is a total runout, and this is a point, And when he to measure, and this is the shaft to rotate a circle to 330 degrees, 360 degrees, 30 degrees, right? Degrees, and we get a different.
The result when we make up the 360 degree is the number, right?
No, just get the one, maybe 60 degrees get one data, and another 60 degrees get another one data, and we get average until 360 degrees. We get 6 data, and we have the average data. That is the one data, right? Average is one data, and we move another point, and to measure, like use this method to measure again, and another data. Maybe we get 1, 2, 3, or 10 data, and we know that is the runout. And is the axis runout. We also use this device to measure this end surface, and to rotate 360 degrees and get another data. That is the axial runout, right? And there is another total. That is different. It's total. That is the circular runout axial. And the total runout radius is mean that the tolerance zone is limited by two coaxial cylinders at a distance of t part, the axis of which coincide with the data axis. It means that from this point to this is to run out, is to move. From this point, move this point, continue to move, and get data. And rotate 6 degrees, and to use that device is to move from this point, move this point. Then another data, and remove, and this shaft remove another 60 degrees and get another data, because this device is moved. That is the total runout radius. That is the difference, okay? And the total runout axial is the same. So the tolerance zone is limited by 2 parallel planes at a distance t apart and perpendicular to the data axis. Okay. Your question? So the tolerance principle, so mostly we use the independency principle. 90% is independency principle, right? Like ABC, there's no relationship. But 10% maybe the material dependency principle, like the envelope requirement. The M is maximum material requirement, MMR. The latest material requirement, LMR. The reciprocity requirement, RPR. So you need to read book, or read the book quite carefully, and to distinguish the 3 or the 4 material dependency principles you learned by yourself, okay? So mostly 90% is the independency principle. The summary. So that is important. It means that how to draw the geometrical tolerance. That is our goal. When the tolerance future is axis, most of the time the tolerance zone is within the space of a cylinder, and the y should be preceded the tolerance value, right?
Yeah.
And the tolerance future and the data futures are always axis or center futures for coaxiality. The tolerance future of runout is always contour future. The contour future, there is no data, right? And the data future must have access. No, this is also control data because that is a measurement. The measurement method to get the runout. So there is a data. And for others, if there is a control future, there is no data. But this is accepted. So the data futures must have access. The center futures sometimes has control futures. The tolerance, the future of flatness, circularity, cylindricity, profile of any line and profile of any surface are always control surfaces. Like this one, there's no data. How this is described the flatness, circularity, or cylindricity. That is like the surface. There's no data. This is accepted. Okay. Get your printed picture and to find out and to correct the mistakes. To correct the mistakes, okay? Students online students, please take out your printers and to do the practice. The first picture to find out and correct the mistakes.
Yes, 老师.
And when you finish that, just take a picture to the group or to the attendant. To here. So this chapter, our goal is to how to draw the picture and how to correct the mistakes. You finished it? Mistake?
Only this one.
No. No. So many.
Oh, okay.
Okay. You need to finish the work in this class. Finish this one and give you the answers, and then you finish the other and practice. Then you get some rules, and then do another one. As for the final test or final exam, we have to say spend time. First, just give you a picture and then to notice the tolerance zone, tolerance or the optical tolerance, or to find out and correct mistakes. Two types. Two answers. equations. Valid them. Yeah. That is very important. That is very important for the engineers. Look the picture. So, okay. This one, you think that's so good, okay? No, yeah. Oh my God. I think that's, yeah, everything.
Here, this is the part.
Yeah, because
It's kind of close here.
oh my gosh.
Oh, that's good. Really?
So let's
Early. It's a form, it's a form profile. I think.
Actually, the part that is here. No.
This is.
The time. The time. Some of them just
is 0.01. Geometric color is 0.01. Is local geometry 0.01. So the circle, it means that this sharp circle, the surface is circle, right? So there's no, the circle is the true with another thing. This data picture. It doesn't, it's not here, circle. Here is in that circle. In that circle is in the tree. Circle, here circle, right?
No, really like. I see here, I hold the number. Yeah.
I think,
Even the data line.
I think. Yeah.
Even by you the last.
Okay, I see this one, okay? Oh no, this is circle, right? Okay, to change the paper, to open the book. Let me see. $20.80. 80. The table 4.1. Like the form tolerance 80.
Yeah, 80.
80.
Okay.
Okay, the table 4.1. The form tolerance. Have you seen that? The straight line, the flattening,
Yes.
the circularity, cylindricity, profile of any line or profile of any surface. Like this, 1, 2, 3, 4, 5, 6. This 6, there's no, because it means the form tolerance. There's no data. It means strictly, the line is strictly. It means itself is strictly or not, right? No data future.
Yeah.
So no data future, it means that there's no
A.
is no A, right? So you need to remove the A. Understand? So and also this arrow. This arrow is needed to point this surface. So this is there here. It's surface.
So
the arrow is here, right? The arrow is here. Is straight line, right? It is okay, but usually we just to point this surface. This surface. Yeah, this is surface. It's here. Here is better, I think, but it's the extension line is okay. Sometimes it's okay. And you said there's no data, there's no file or not, right? Right? Confusing? There's no file or not? Confusing? Or not confusing?
There's no file.
No file. Yes, there's no file. Right? No file, can you understand? Because this is the surface, not our axis. So this is the surface. Change the contour. The page 82. So like the surface or circle, so with the circle, put your hit with the circle to control a point with the plane. Circle. Well, the circle, there's no circle. No. Let me choose. So there's a circle, right? It's a circle. Actually, it's real circle is imagined here, right? This is the circle, right? This is the real circle. So we use a theoretical circle to contain the real circle, right? So his content is a circle, right? The circle is no phi, no circle. It's cylindrical. Phi it means this is a cylindrical. This is a line. It's a line needed to contain this line. We need a cylindrical and with a space line.
Then we need phi.
And we need to add the phi. Why this line is a cylindrical line? It's a space line in no direction. This is a straight. We need to contain the line. We use a cylindrical to contain the line. And at this condition, we need to add a phi. Okay, this is the first one. This one, this is what? Okay, this is a concentricity, right? This means that this concentricity means this axis is concentricity with this axis and this axis because AB, HB A is here. But this is the axis. It means this axis. So A is put wrong position. It should to in the line of the dimension line, right? Because this is the axis from this one. This is A data. A data is needed to describe this axis. So it should to put here. Right? So B is also to put here. The axis. It means that this concentricity and the coaxiality, this right? So it means this axis has a concentricity to this axis, So this is also to describe the axis. So this arrow is put here to in the line with the dimension arrow, dimension 9, right? Here. And also it leads to add 5 knot. No. This one.
Yes.
Yes, it needs to add the 5 because this is the axis. The axis is a space axis. Space axis. The axis we use a cylindrical to consider this axis. So this axis it has a coaxiality to this axis. So need to add a 5. Like this one, coaxiality. Here, right? Coaxiality this one. Okay, this one. And you need to add a 5. And this one, cylindricity. The page 2080. The cylindricity. You like this one? Cylindricity is you think it's little to in the line of the arrow line or not?
No, no.
Not right, because this is the form tolerance, no data, right? Form tolerance, no data, but it describes the cylindricity is here. Cylindricity, the shaft is cylindricity is here, right? Understand? Huh?
Is there any difference if we put if we put A,
A.
then if we put it to not
I can send you use A here.
you think we have to change it?
A to here, yeah, to here.
Okay, now
And that is the line.
is there any difference if we put it here or if we put it here?
Put it here, and B put it here.
No.
The rules is usually you need to you have the rear. You have the rear. You don't need to change the symbol, right? Because this is a circle. This means circle, but you to change is the parallel. No, it's not right. It's the basic principle. So the A is here, the B is here.
It's clear symmetry.
But why do you want to change that? You change the B to here, you change A to here,
If you change
right?
You will change it.
You do not. It's not meaningful. You mean that? You mean that A change A to this line, right? Change A to this line. B to this line. You mean that this is not meaningful? Why do you change like this? What's your question? It's okay. I'll continue.
Explain the question.
And this one is the total circle run out, right? Total run out.
Total run out.
So it means that is this. You see that it's run out. This total run out. The run out is means that the surface, right? But this line, this error is in the line with the dimension line. So this it means that the axis, right? Like this one, it means the axis. But the total run out is means the contour feature. Contour feature is means like surface. So you don't need to put the error in the line, in the dimension line, right? So you have a position like to usually we would put the error to here to surface, right? The run is surface. So do you think this is a 5 or not? This is not 5, right? Because this is the total run out, not like the axis, right? So the A data A is here is right because A is here. We have already to correct the A is here to describe this axis, right? So the answer, right answer here. Okay. So like this one, this is here. The cylindrical is not the axis, right? You can understand? You need to see it and understand it. When you come back, you need to check the book or watch or look at the book or see the book from page 80 to
Also,
hmm?
you say there needed
Page 100. Where?
here. Five.
Oh, sorry. There's no 5.
So.
Yeah, this has 5. Sorry. Yeah, it has a 5, right? It's a 5. Sorry. How do you change that? The 5. Five. Oh, no 5. So there is no 5. Okay. There is no 5. There is no 5. Okay, just please to do this one. A question? There's no 5, okay? Stress, there's no 5. There's no 5. 5. Yeah. Okay. Yeah. No data. Here. Yeah. And this one. If you don't know how to do that, just to check the book from 80 to 100, 102, 102. Just to check the book very carefully. PH, sure. PHI. What is the PHI? Hello, everyone. No one respond me.
Yeah, there.
Huh?
Yeah, there.
They are there. That's the to send the two students here.
That's not. Yes.
Just send the picture or to the group, to the WeChat group, okay? When you finish that. Just those one here. I didn't write.
Yeah.
But I don't know how to change that one. I think this back here.
Oh.
Right here. Yeah, I did that.
I think we got this one. Alright.
You see that?
No, yeah, not correct.
This one, so right, when the arrow line, even now the relation line is in the private axis. Maybe the axis has a circle? No. The principle is that you don't need to change the order types, okay? This is why you need to change that. This is circle. No, if it has a circle, it means this is so this is the finished. Finished position. Well, this is the 9, this is the 3. So we need that is 9, we change that. This one here. Here.
Line there.
if this error is unexpected, this is the 9 here is 9, dimension 9 is this. Right? So it means that this is right, all this is this one. So you are considering that. So that what is this whole is a whole so 0 by 0 is in the pattern. Then yeah, how this is lost. This is student, yeah, student is not be the data, right? Yeah. If you remove this, yeah, no.
We remove this bit because of this strength in strength also
Finish.
Why?
Yeah, found this one is the yeah, but the concentricity is like the in that is that and this point is that right? Yeah. Like B, I don't know, like B. It is here, to solve it. Oh, so but and this because then that.
Yeah.
You mean
If I see here.
yeah, H but so you interested in the detail that you know possibly this and you are a person like if you got not people communicate it also in this message
The same.
the next thing yeah, it's the data block. Yeah, so no. Yeah, so we didn't use that. So no. And so we have this is so
It's not.
they have rights. Yes. And also another thing. I mean, this that is 9. That is the total point, right? Total is total. So
Yeah, so you
it's
should point to the
total.
okay.
Because the total, right? If you run the total, right? Total is that is the total. But this format, the social form, the string, and this is the chip. The technical chip is not.
Yeah.
It's just line. But total the chip. Yeah.
No.
Yeah, because this is the
Yeah.
yes. The analysis. I said that I already did
That's not.
it today, then this for 2 weeks.
That's not.
You have already that. Let's do that. Let's do that. You have finished good? Yeah, this one. This one. This one. This is right. No. Okay, this is the 3 right? It's 50. Using the data, take. And that this 1, 2, 3, 4, 5, 6, this is not data because this is the 4 column. And also this is the cylindricity. It is the cylindricity indeed. If the line is a line, the dimension line is the axis. This should be here. It's the cylindrical line. It means that is the cylindrical. This is the cylindrical. Mean what?
I mean, if it's here or there, you can see.
It's even here. No, because yeah, the same stuff is but when this line arrow in the line is the dimension line, it means this one, it means this axis. That means the axis has a cylindrical. You think it's right? No, it's right. So you need to have a move here. Okay, and this one is the concentricity, right? Concentricity and concentricity. But this it means that this line, this is the axis line. This axis line have the same axis with this line, with this axis, right? So this has A, this has A. So A is wrong, right? Okay, there, how is going to be?
A is wrong. Why A is wrong?
To see display this one and this one and this one, okay? See you. No. No. You. You don't have to type.
I don't understand how
Yes. This are
Why?
I see two things, but you don't understand anything. It's hard. It's tricky. I don't see the.
So this arrow.
Yeah. This is so. So it's that. Right? It's not so. So it means that it is still the data, right? Because it is still the so. The data is right. But when that is a line of the dimension line. It means this is right. So when this line is a line, the dimension line is the axis. All right.
yes.
So it is that
But now,
that cylindrical is the so-called right. Right? Or this is the whole. The whole is the right? Yeah. So this is a solution here. And also in the line is the so-called. So-called is part of the jump. It's also so this is the
One
yeah, because this is so no fact, right? When we describe
Why you don't see? You say that people this.
Yes.
And design will continue.
Yes. We should have added
concentricity on the axis. Okay, this concentricity is that this axis has the axis. So it means that this line here, it means that surface.
We want to
Surface. I just say not right.
Yes.
Wait, so this arrow is to here to the line. when you see the
因
line,
为它这个还会在家这里面，
the year is the first one,
Yeah, it's supposed to be this
and
year.
author A data. A data means that this act has the same sex to this.
You will never get back.
Yeah, should be fine.
To the line.
Yeah.
The line means that
She's big.
they are means that this is
That is
described this act. It means that this act has the same act.
this arrow.
It means that this act has the act. So when you drill a hole, this one, and we solve this one. When you drill a hole, this one has an act, and also drill this hole and the last. So we need to make sure this act has the act. The point. And usually I'm talking about.
There's some of the projects on it.
Yeah, it is at why. Yeah, not valid. Contain this the double direction. The space. Yes. Not one. This is the.
Yeah, you know.
But here, sorry, here, and that's on here and this bar, but here doesn't have.
The file is supposed to be.
It's a cell.
So you need the actually I've not found the mistake I found this way. So you did.
Yes, but I found this to straight line, this one,
Straight line to
this one, that is gotta be. Because the definition is
And also,
flattened.
when it's nine,
the mistake I found the simple control. They change the number and the symbol. The symbol must come from
Reference, interference. Everything is like it. Everywhere.
Yeah, the symbol is supposed to be going on. The number comes for the symbol must be a reference. But here, it is the reference. But this is a symbol.
This one
That's
is
when it has
surface. This one means this surface. This surface is described.
Abstain.
This surface is
We have like this. That's fine. Oh,
the B is entirely perpendicular to this actually flat. Yeah, because the surface is that. Next one. This one. This is straight line. This is straight line. Do you think it's really straight out of down? That is the one column, the data. One way four five six. This is the data. The data is the data. Okay. So this is the line. This is parallel to this line. Right. Also, it describes the line. That is circle. That is circle. Circle is meaning that it means this one. Means this circle. This is circle, right? This is the circle. So the circle it means that in the tree.
I was saying,
yeah, we talk about to us about it. To show them. No, it's not also fine.
And do you think it's more bias?
Okay, before that, don't say like.
Yeah.
Why?
So much money behind this.
You know how they have.
How much is it?
Because
How much?
you needed to turn it up.
Sorry, yeah, why?
Okay? You need to turn it up.
And then I'll walk. Yeah.
Yeah, it's just like that.
How?
Because then, because you need to perspective.
China is one down. They're the richest country in the world.
That's also.
This is also this is the yes, this is one okay. This is the first option. I did this is okay. So before because
They misunderstand. United States.
oh, yeah,
I saw they show me.
we are in November. I thought that this is video later back. You please more than that.
Yeah, like next one opportunity.
I see here. Single chain.
I know. This one is wrong. The single is the right. Yeah. Come here. You need to practice all of that.
Yes, but we want by this class. Wait, communication. Asking me to do the next one.
Yeah. You need to finish the all of that. Okay, please take this. Cambio. Yes.
In 1 month, they will get more than 7 trillion. Now, getting said, I can explain about this English. It's less than 10%.
No, más lo dinero también.
What you say? Actually, because it should be the same. There's the rules. What's the question? No one. Oh, yes.
That's not fantastic. Fantastic.
No, that.
It's a word I like to use sometimes. See?
So why do you like to rest? Why do you like to rest? Why do you
The doesn't show the shape of the drown's eyes. He like doesn't show the shape of his hips.
That's all I like.
How's it?
Oh, Lisa.
I just feel comfortable when like we
Yes.
And that's it.
Yeah. Yeah. Bye. Yeah.
Oh, yeah, this not the primary. Science.
So this is
Something
Yeah.
So actually, this
Yeah, and I can solve it. You to myself,
and
Fantastic.
What about circular runoff?
Finish that. Finish your bed. We need it.
So someone is saying that in the second figure, right?
Secular,
Right,
yeah.
the second figure. Someone, he says there's no mistake there.
There's a mistake there. Which one? Which one?
There's, yeah. This one.
No, this 9.
Actually, let me start again.
You mean this 9?
Uh,
This 9 is this 9.
Really?
But I have to change this one.
Yeah. And
This
then
one is
touch this
here.
one to surface.
Yeah, surface. Yes, the surface. But this we need to add the data. But spot.
5.
Because it's the axis.
So why 5?
Because this is the axis. The axis is straight line. I mean, when you change this to here, have to change to here. It means the this axis is straight line. The axis straight line is needed to alpha.
Here.
Yeah.
Before that one,
You have to place it.
here no name 5. So why can we?
Why is that? Because this is to arrow to change the figure. Right? The axis is the space. Is the cylinder. Yeah, it's the diameter. And this one is the surface. This is the surface. The surface is the surface is a line. That's the one direction.
But actually, that is it is the only
You didn't use this one.
because if you move it, it becomes something. You have that.
Yeah.
So we need to use it. Yes, yes, fine. So yes, it's that's yeah. That's
Come here.
yeah.
So we'll solve.
Yeah, that's surface. Yeah, this is
You need to have 70 expand this. Expand this. This standard, so it's talking about the data, right? So straightness of what?
What's the name of
That, and this one is straightness. So it needs what? This 5. But this is perpendicular. Perpendicular to B. Which line is perpendicular to B? Because this is B, so it means this is the surface of B, right? So this is surface of B. What's perpendicular? X, which means B is here. This line is here. You understand? So the arrow for this one goes here, and the arrow for this one stays here. And then you add a 5. Because now we're talking about the data. The arrow of the marking is in line with the arrow of the cylinder. You understand? We're talking about that, and the data represents the cylinder. Cylinder is the diameter, and the diameter is 1.
So it should be.
Yes.
Now she said split them into 2. You understand?
Yeah.
When you split them into 2, this one is straightness, right? Straightness of what? Straightness of this diagram. So it needs a 5. You understand? And this one is what? Perpendicular. 0.5 tolerance perpendicular to B. And B is like this. The only surface perpendicular to B is this surface. Right? So it means this line. So,
Then that's the reason why you move the B.
which B? You don't remove the B. You don't
You
remove
move it.
You don't remove the B. This is perpendicular. This and
You need to know how to
you
read.
don't have to remove the B. Yeah, this B is here.
It's there in
It's here. You know it's there.
It's the measure
That's
line.
done. Yeah. Just sing it. Reference species or reference surface. That's that. But the same So here, down here.
Okay, 28. What was 9?
Then
Actually, I was going to have the video there.
Huh?
I was going to have the exam.
We have to do that.
Final examination. I was going to have it.
We have books.
Yeah, options, yeah, we gotta have.
We have books.
Because,
You know,
you
sometimes-
know, it's just
Yeah,
saying
it's
that
like it's not
it's
okay.
Okay.
Yeah, options.
With the open book is there. How about you have to first?
together.
Yes, maybe important.
Yeah. Yeah, we get pretty good nice now. This one. Yeah.
Okay, that's very hard. Okay. Is that I can find the same.
No, it's not the same. You have just
Okay, different book. What book is there?
This is B, right? This is B. Perpendicular means they should intersect at the point, at opposite, at vertical, horizontal, right? So this is B. There's no way B can be here. Here. There's no way B can be here. If B is here, this line is not perpendicular to this. You understand? You get it? It's parallel. So because this line is not perpendicular to B, that arrow that is pointing down cannot be for this. You understand? So you get it? Yes. So the only line perpendicular to this one is this surface. The other one perpendicular to it, right? Which means this marking should go here. You get it? So that this one can be perpendicular to this B surface. And then for the straightness, already straightness 0.02. So this one, in the beginning, you already saw this arrow, right? Which means this arrow was for one of them. You understand? So this arrow, which one can it be for? It can be for the straightness, but straightness of what? It's pointing, and you also say whenever it's pointing to this arrow, you're talking about that, and it's pointing to here, you are talking about surface, right? So now I'm looking at the straightness of what? This that, and this that is just a space in the cylinder, which means what? There's a diameter of the cylinder, and the datum is in the middle, right? So if there's a diameter of the cylinder, it means you are looking for the straightness of what? The datum, right? So if you are looking for straightness of the datum is a cylinder. You need 5. You understand?
Yes.
Okay, continue. Hello everyone.
This one has
It's
got
not
to
done, but it's not done, right? Yeah, correct.
Now she said the last one is the homework. This one. Oh, you mean the rest?
There are 2 papers. There are 2 papers. The homework, right? One.
It's the same, it's only one paper.
Oh, wait.
This is the homework,
Because
the last one. But actually, this one, you're supposed to write it ourselves.
To describe.
Right?
Yeah, right. This is the mistake. Yeah, write by yourself. This is to find out and correct the mistake. And that one is to write the colors by yourself. So everyone understand this one? This one?
You have to make sure that the combined option. Maybe they need explanation.
Huh?
Student overseas.
Students overseas cannot understand.
Maybe you have to explain to them.
I will to send this to them. This PPT to them. Okay. And this one is not right. It's to like the says to here. Parallel is perpendicular to the axis. I will send to you. I will send to you with PDF. And this one. Have you understand all of this? All of this? Understand that? Wait. Oh, okay. Understand that? This one, circular cone. This is draw this frame by yourself. The circular cone circularity is 0.01. The first one, the circular cone line straightness is 0.02 millimeter. The concentricity of axis of phi here cylindrical and here cylindrical with the common data straight line D1 axis and his axis are 0.05 respectively. Plane circular run out with common data straight line of data of phi D1 axis and phi D2 axis is 0.03 millimeter. Just quick draw the frame and the tolerance type to this picture. Yes, right now.
Say, control. Delete that.
You have finished it?
No.
This information.
I see.
Information. This one. Guys, the information and
Behind.
Exactly.
Circular form.
It didn't cost. No. Not because you had. Circularity.
So I say you not understand.
Understand?
We on the so
Yes, you have to draw.
Yeah.
Here.
Yeah.
We're going to this later. Here, the pencil, here.
You need to ask me.
It did not be
That you ready quickly.
quick, guys.
Yeah.
This is the same. Hi.
Forma circular.
Use homework, this practice. And you can get a pass with the valid exam.
I want to ask, we are going to last. I mean, that is here or here.
Circular form,
Is there? What side?
circular form,
We can give,
circular form.
we can give name of this one.
Yeah,
A, B, we can.
yeah,
I mean,
I got
you
it.
have to be like this and 0.01, right? No, but.
Yeah,
No, but. So how do this get?
yeah, I think it's circular form.
So much in the class.
Right? It was a job.
Because you.
How we have to. So, yes, and then. Okay, this is. Go back.
The circular form is here. This is the circular form. Okay, so this is the circularity. Is this circular course circularity? And circular course line drilling is means this line is a line drilling. This line drilling and this is circularity. Concentricity or axis of this one at concentricity. It means this axis, right? Concentricity of the axis. This one axis. And this one axis. With the common data digit 9 or 5, 1, 5, 2 in 0.05 respectively. It means this is 9. This is data, or this data is the same. This is concentricity. 1 is D2, 5, 2, D2 is D1. They have the same common data digit 9 of D1. And D2 actually respectively. Finish this? So this one okay, A, B, this is A, this is B.
So
This
I should give it to me.
yeah, A, B, this is A, B.
It's straight to the name.
Yeah.
This is circular.
Six.
This circular form is here. Circular form is here. This means this surface. Having you will down looking like this. Yeah. An arrow. An arrow. Yeah. Yeah.
Also circular anomaly.
Yeah. And number 50 here. With this one, what is it? D2, D2, D1. Everything, the concentricity of axis D1, D1 is here, right? And the D2, D2 have concentricity. Which is common is line of D1, of D1, this one. Of the and D2 axis up 0.05. I think it is what I found this on the yeah. And of almost it has to be 1 yeah. And the data three. And also the red is here and it's yeah. That's standard. There is a
The same line.
what? 0.01 or
Yeah.
kind of type.
Run now.
Circular.
What?
Run now.
Bring to that. No. I want to display this one.
Oh, circle.
Okay. Please.
Circle.
Okay. Please see the black. See the. Please see the not black. Please the PPT. The first one, the circular core circularity is 0.01. The circular core is means this core, right? Circular cores.
Straightness there.
Circular core. Core. This is cone, right?
Yeah.
The circular core means this surface or this circularity. So the circularity is showed. It's a circle. Circle is showed to perpendicular to the axis. So it's to perpendicular to the axis. So it's circular is 0.01. Please see, okay? And the straightless. The straightless, it means the circular core straightless. It means this one. So the line is 0.02. Okay. And the concentricity of axis of D1 is here, and the D2 is here. His axis is here. So the axis is here. So you need to write the dimension line. Dimension line.
Yes.
And this concentricity line is in the dimension line, right? That means describe the axis, right? So this axis has the common data straight line of this D1, D2, have this data. It means that this axis and this axis has the same data. They are the data, and also they are the geometrical tolerance of the features. They are the data and they are the features.
Instead of writing this A and B, if you write A1 and A2, it's wrong, right?
You mean that? You mean that we use to write D and D2?
Yeah. Instead of writing this A and B, I write this ID1, ID2.
No,
It's wrong.
it's wrong. Just the D and 2 and the A is here and the B is here, not like D1, D2. This is the standard. A to B. A, B, C, D, E, F, E, no, not E, A, B, C.
You leave the name A and B.
This is standard. I'm the last class. I have already presented that. This is the type. This is the word value. That this is A, B, C, D, not E, because E is for another use. And it to F to A, B, C, D, E, F, G, or something is rented. And the A is here and B is here. So it's standard, not D and D2. A to B. Okay. You understand?
Yeah, we understand.
And the plane one, plane I, the circular run out with comma data straight line of D1 axis and D2 axis is 0.035. Like this one, this is run out. The value is 0.03. It's A to B. The data A and data B.
And this concentricity. We need to write
Concentricity here, yeah,
you need to write it 2 times.
2 times. Yeah. Because this is the data, and also this is the futures, the tolerant futures. You just write one. I think it's right. The median page is right. What is the concentration?
Yeah.
Not is medium base. This thing, right? It's not the one. Yeah, it's lovely. Like the people.
No, sometimes you answer the same.
Yeah.
You hope it's going to sleep.
You understand, no doubt? Next one. Okay.
Actually, my one division, what are we supposed to see?
When you finish this one, I just do another practice. Next one.
Actually,
Huh? Yeah. The maximum variation of the medium plane of the group is the medium plane of the less than 0. That is here. Maximum variation of the medium
it's done.
Is the paraplane with the to delete it, there will be one with the ones. We need that. This parallel this line, this line, this plane, this place. There are one yeah. Symmetry. The media play, the media flows. In this line,
For this in
yeah, the media flow. The dimension, yeah. Yeah. And so the spots are not that. And the work is not.
So yes, yeah.
Next one, next one. This one. Finish that. If you don't have finish that, just leave you for homework. Yeah. And then
I know.
Bro, but
But you need to start to talk. This one.
It means the maximum variation of media relations. The group, the group median, the median line, the median line. This is median line, right? And maybe the first to the median plane of the work. To the median plane of the work, it means the median plane of the work. The problem, the B is means this surface. But which one is bigger plane? This is the bigger plane. Yeah, this is bigger plane. This is the tree, right? The data. The bigger variation, bigger velocity, the bigger plane load, the media plane load, the data. And now the professional yes. That is so this is the A, B, C, D, the B, C. When A, that level is the A for what? The little A. Yeah.
Yes, I didn't know.
Now here, after you don't choose. That is the axis. See, the axis is on the
Oh, yeah.
yeah.
Ah.
Yeah. Yeah. So you can either about the parallel
Hey.
Oh yeah. Yeah. It would be on you. 很漂亮，来，两个是都可以是 parallel，
This one, this one.
Everything that is that that what's in right is something.
You understand the picture? Yeah.
No,
It's the rule. Sometimes you got to ask why. Just accept. If you want to just one, why? Because you can ask.
No, it's a loss. It's you just
This one,
right
this
thing.
one,
The loss.
this one,
Like A.
this one, and this one.
And A is the rest of it. A is the rest of the loss.
So this one is next.
Oh, A is so.
That
B is the
that
and it means that
That's
all that was later. Some people also the A those
symmetric.
this one is that.
This is the medallion.
The first one, the first is the medium thing. This two is
Yeah.
later. This is the maximum. So the blue is this one. The medium little blue.
Is that? Yes.
Yeah, this is how you use the dimension line to derive that.
To find the symmetry, this one is nine. What's the area?
Which one?
Oh no.
This one is the
Of the this is the one. The medium plane, the medium.
So like this is because it's the future, right? Center future we use to describe like this two in the line, dimension line. Already seen a lot of times.
What's the highest that you use like this? Like this is number one. That's the limit. When we see how much Because if you cast this,
所以呢，这个这个多，这个多。
that is one of the strategies. This is
Because I'm not looking at all these and okay,
It's usually one, right?
Last one for the homework, okay? That, I think they change the question. Okay. Stress, you need to change the question, is this one, to the common axis. If this that we have and the class over. And the last one.
Or which now?
More,
You just need more right now.
you need more practice.
Yeah.
I fear,
More.
I think about, I think about a lot. Okay. Sit down.
Actually, I mean, we need to practice more.
We.
You do this at home. Don't do it.
Okay, I mean the question, the first one, the question is a little round, just like this one. I sent you to PPT to your group, okay?
Yeah. Okay.
The circle round out, the circle to the common axis is 0.05. I mean the practice, you print a little round. The first question one.
Yeah. You try to create this stuff.
The question one, I think the question you print is a little wrong. So you need to change it.
Okay.
Change to this one. I think it's easier to understand. Understand me?
So let's take a picture of this one.
Okay. There. Take a picture and let's send to your group.
I'm saying picture of the you know, like,
This one is somehow we believe
You need a more practice.
yeah, actually, this is now. This is more practice, more practice.
we need.
You need a more practice. I will find it.
Okay.
If I can find more,
Fantastic.
Maybe.
I just translate.
Maybe.
The Chinese, this is for Chinese, I translate to English.
Maybe it's beyond the fact that they don't have.
No problem, okay?
Taking picture. How can you lens?
Okay?
What you know?
Yeah, I can't, no yet, Who sent me?
Oh shit.
I can't, that.
You guess.
You guess.
No.
Oh, that. Could you send to the group?
Send it to the group.
Class over.
No.